in case of scalar data types, every variable or every signal will going to hold one data at a time. Okay, and in that the values can be compared, where we can consider a set of values that belongs to a particular data type, and each element will going to hold one particular value at a given moment of time. This is how we are going to consider scalar data types. In that, mainly we have discussed regarding enumerated data type, where user can able to define his own data type, and in the order in which the elements are placed in the list. According to that, the relationship with respect to the mm, numbers or the elements will be considered. That is what we have discussed in enumeration data type. And next data type what we considered is integer data type. In integer data type, mainly to hold the integer values, we are going to consider integer data type. Especially they are helpful in counters, and when we are going to declare the vector size and all, there we are going to consider integer data type, and also to perform the arithmetic operations and all. And here integer value range will be from minus 2 to the power of 31 minus 1 to plus 2 to the power of 31 minus 1. So this is how it will going to consider the range of the integer data type. In this integer data type, another part of the integer data type is also known as subtype, and one of the predefined subtype available in IEEE library is natural, where we are going to consider numbers. All positive value of integers are considered as natural numbers. Okay, and next we have considered regarding floating point number. In this floating point number, only to hold the real values, means if any fractional part is present in the number or the fractional data has to be processed, in that case we are going to consider floating point numbers. And the range of the floating point number is minus 1 1 e to the power of 38 to plus 1 e to the power of 38, where e represents the exponent. So like this we are going to consider floating point data type. Usually this floating point data type is not synthesized. Very rarely we are going to consider for synthesizing. Why we are going to consider very rarely for synthesizing means, when we are going to consider this floating point number, it compared to integer, it is difficult to design a circuit with that floating point values as a input or output, and to hold the data or to perform any arithmetic operations and all, it will require more circuit complexity will be more compared to the integers. So that is why usually we are going to consider integers, and very rarely floating point numbers are used. And next, one more data type we had considered is physical data type. In case of physical data type, we every element will be having a unit along with the value. It will be having a unit, means usually when we want to measure any value in terms of units, we are going to consider physical data type. For example, area of the given object, or if I want to find out length of a particular distance, all these things we are going to consider units to measure them, like meters, square centimeter, like to measure area or to measure volume. All these things we are going to consider units. In order to hold that type of data, we are going to define physical data type. And one of the predefined physical data type available in IEEE library is time. Usually we are going to represent time in terms of integer values along with the unit, seconds or nanoseconds like this. The basic unit considered for time is femtosecond. And using this femtosecond, picosecond is defined, means 1000 femtoseconds is equal to 1 picosecond. Similarly, 1000 picoseconds is equal to 1 nanosecond. Like this we are going to consider the time data type. And while defining this data type, we are going to use the keyword type, and then we are going to mention name of the type, and afterwards we are going to mention the range, what values this particular data type can hold. That is nothing but integer range only we are going to consider. Minus 2 to the power of 31 minus 1 to plus 2 to the power of 31 minus 1, and this is the range. But in order to represent each value, unit is associated, isn't it? So unit for this data type is defined as femtosecond, and using this femtosecond, this is how we can able to define the next units, picosecond, nanosecond and all. So one, but the basic unit is femtosecond. Like this we can able to define physical data type. And next, let us consider composite data type. Composite data type means where every element can hold more than one value is known as composite data type. In that, first let us consider a simple composite data type, that is nothing but arrays. When we are going to consider array data type, where every element can hold more than one value at a time. And for example, if you want to consider a bus, data bus, so in that case we want to transmit 8-bit data at a time, or we want to receive 32-bit data at a time. So in that case we are going to consider an array or a vector of 32-bit. Vector is nothing but unidimensional array. Vector is considered as unidimensional array, and some of the predefined array data types present in IEEE library are bit vector, std underscore u logic vector, as well as std underscore logic underscore vector, where vector indicates array. If I simply mention bit, it is considered as one bit. If I mention bit underscore vector, it is considered as an array of bit array of elements where each data is of type bit. So here we can able to see the type definition for bit vector. So bit vector is name of the data type, and it is defined as type bit vector is array. So this array keyword indicates that bit vector will going to hold multiple values. Each element or signal or variable can hold multiple values, and what is the number of how many number it can hold at a time, that is represented as range. Okay, and each value in that element is of type bit. So like this we are going to mention. For example, if I am going to consider a is a bit vector, means if it can hold 4-bit value, means within double quotes if I am mentioning the value as 1011. Okay, so in that case it is equal to a array, one dimensional array of 4 elements, and each element is of type bit. Bit means either only 0 or 1 can be present. So that is how we are going to consider. Bit vector bit vector is a array data type, and its range is natural. Why the natural range we are going to consider? We cannot consider the negative value. So yesterday I have mentioned the natural number represents all the positive integers, 0 and all the positive integer values. So the dimension of any particular signal or variable cannot be negative. It can be positive values. So if I mention it as integer, then the range can be negative to positive because it can hold both positive values and negative values. But when I mention natural, then it cannot hold negative values, only positive values it can hold. And this indicates that entire positive values are considered. In case as natural is a subtype of integer data type, it can hold all the positive values since the range of integer is uh, positive. Maximum positive value of the integer is plus 2 to the power of 31 minus 1. So as a result, the range of natural number is from 0 to 2 to the power of 31 minus 1. So this will be the corresponding range. In that, how much we want, we can able to consider that particular bits. So that is why while defining the data type, we are going to mention a bit vector as 3 down to 0 or 0 to 3. Like this we are going to mention a vector. Okay. And similar, like how we are having bit vector, similarly we are having std underscore logic underscore vector. So where all these array data types are having a range of natural number, and each element in this array is defined by this particular data type. When I declare any value as a bit vector, there I cannot mention the value as 1 x 0 u. Like this I am not able to mention because x is not present in bit vector. X is present in std underscore logic. So while defining bit vector, I have considered that every element is of type bit. But if I declare this value for any signal of type std underscore logic, then this is valid because std underscore logic is having the symbol 1, x, 0 as well as u. So as a result, it can hold all these values. Okay. So that is why while defining, we have to consider the corresponding data type of every element in the array. And one of the example what we have considered is here. If I consider signal A of type std underscore logic underscore vector means, here I can mention the range. Even though I will not going to mention the range as natural range, because while defining in IEEE library, there the range is not fixed. According to the requirement, the designer can select the range. That facility is provided in the library. But while writing the program, we have to take fixed number of range. So that is known as constraint we are going to consider. Range constraint. Otherwise, it will be considered as unconstrained array. Unconstrained means where the range is not specific, but here the range is specific. And here it can hold 4 bits of values, where MSB will be considered as the third bit and LSB will be considered as the 0th bit. Always whenever we are going to write like this, MSB will be represented in this position and LSB will be represented in this position. If you want to reverse the order, then what we have to do? We have to consider 0 to 30. It is not up to 30, sorry, up to 3. It is 0 to 3. In such case, we are going to consider 0 as is 0 in the MSB position and 3 third bit in the LSB position. The bits has been reversed. Okay. So like this we can able to consider either down to or to. We are not going to consider up to. Okay. And one more thing, where we can able to define our own array data type is like this. So here we have considered type word. The name of the data type given is word, and it is an array of 16 elements. and each element in the array is of type bit. Whenever I define a signal B of type word, it indicates that it is having 16 elements of one dimensional array. If I want to consider two dimensional array, then here we can able to define, means the range will be separated by comma. So we are going to define two ranges. So one will be representing the number of elements in a row, like how when we consider matrix we will going to consider rows and columns, isn't it? So this will be represented by row and this will be represented by column. Means there are 8 elements and each element is of 4 bit. Like this we are going to consider. Okay, if I represent in terms of a matrix, means I will be representing 8 elements and each element number of columns means there are 4 columns, isn't it? So as a result we used to get number matrix representation in this format. Okay, so similarly it can be interpreted as array is having 8 elements and each element is a 4-bit array and each data in the element is of type bit. Okay, like this we can able to consider. Whenever I'm going to consider a data type of table 8 cross x, in that case it indicates that it can hold 8 elements with each element of 4-bit size. So like how I have declared signal B of type word, in the same way we can able to consider signal C. If signal C and of type signal C, and here I can define the type as table 8x. Okay, so when we are going to consider signal C is of type X, means it can hold this many number of data, that is a 8 elements with each element as a array, table 8x. So like this we are going to declare. What is the advantage of declaring the required data type is we need not necessary to always mention the dimension. Simply if I mention this particular value, in that case this particular data type, in that case if there are 10 elements of this data type, all the elements can hold this much data. If I declare around 100 elements of this type, means all the elements can hold this type data. Otherwise for every element I need to mention the dimension. Instead of that, according to the requirement we can able to define the required data type. When once we are able to define the required data type, then programming will be easy. Okay, for that particular reason we can able to define our own data type. And you can observe that here I have used underline. So underline is not processed, it is not considered as a value in the number. This is just for user convenience. Means if more number of bits are placed consecutively, for example if 32 bits are there, then if any one bit is missing, it will be difficult for us to notice, isn't it? So in order to read the value comfortably, designer to read the value comfortably, we can able to insert underscore wherever the position, in whichever the position we want, we can able to insert underscore. If we can able to read 4 bit at a time, then after every 4 bits we can place underscore. Or if we can able to read 8 bits at a time, then after every 8 bits we can put underscore. So like this we can able to consider the corresponding data type array. And in this array data type, underscore are mainly used to represent the data where user can easily understand the number of bits or number of elements present in the array. This is how we are going to consider arrays. And next what we are having is record data type. When we consider record data type, here not only one type of data is present in all the elements of the array, there may be more than one type of data can be present in a defined data type. Here, let me explain this example. So in this example we are going to define a data type IO cell. Okay, in this IO cell it can hold 8 bit vector, means binary data, and the another one as enable bit, and the another one as output buffer, that is nothing but another 8 bit data. So separately it can hold 3 data, I mean 3 arrays. Okay, so here if I declare any signal, here you can see the example signal bus A, bus B, bus C or of type IO cell. So in this case what happens is, whenever I'm going to declare bus A as a signal, it can hold first 8 byte of data and another one, sorry, first 8 bit of data and another 1 bit is considered as enable bit, and the next 8 bits are considered as another the vector of 8 bit. So like this we can able to consider. So here you can see the example. I have just taken a signal VEC of type bit vector 7 down to 0. And now if I mention, if I want to load the corresponding value present in VEC for the signal bus A. Okay, so if I want to load this as a input for bus A, but bus A cannot hold only 8 bit, it can also hold this bit as well as these 8 bits. So simply I cannot mention bus A is equal to vector, because bus A is not only a 8 bit vector, it is having 3 different elements, fields in the data type. So the first field is 8 bit, second field is 1 bit, third field is also of 8 bit. So like this 3 different fields are there. So when I want to place any 8 bit data, I need to select for which particular field I have to place. So here I have considered bus A dot buffer underscore inp. So it represents the first field present in the data type IO cell, and for that field vector data will be placed. And similarly for bus B I can able to access a particular field of the bus B and I can able to update that. And similarly we can able to enable, send only one bit for the second field. So here I have mentioned bus B dot enable is equal to 1. So the second bit is enabled by the bit 1. And next, if I mention bus C is equal to bus B, then all the 3 fields of bus B will be copied to bus C. So like this we can able to hold record data type. And in this data type, we in this example we are seeing that only bit vectors are considered. Suppose if you want to hold a record of, let me consider a classroom record. So when I want to maintain record of individual student, there how I can able to define the data type. So in that case I can able to define the data type as type and then stud underscore rec. So here the name of the data type is student record and it is of type record. Okay, where it can hold many fields, not more than, sorry, not only one field, more than one field. And here this, in this the first field, let me consider the first field as name. Name of the first field, sorry, identifier of the first field is name, and here I am going to represent this particular data type, isn't it? So in order to represent this, I'll use the USN. So for USN, we will be having numbers as well as alphabets. So mainly to display the string and all, we are going to use numbers and alphabets, isn't it? So there I can able to consider the corresponding USN, or just instead of name, I'll just mention USN of every particular student. So there it can be a vector. What type of vector? I'll just consider it as std underscore logic underscore vector. And usually how many characters will be present? Usually if you are considering the roll numbers and all, in that case, let me consider it as 2 down to 0, down to 0, so that it can hold these many elements. And similarly, after USN, we should know for which particular semester they belong. So I can consider the another field as SEM, and here it will be only either first, second, third, up to 8 semesters, isn't it? So I can consider integer. Okay, the semester is an integer value and its range is integer range 0 to, integer range 1 to 8. So it can hold only these values. So like this we can able to build the corresponding record. So in this case, here you can observe that according to the requirement, I have defined my own record data type. In this, it is having only two fields, USN as well as semester. And then for every individual student, I need to give the corresponding USN, and then I need to mention for which particular semester they belong. So like this I can maintain the record. And while declaring the signal, I can declare it as signal and let the student name be A, B, C, and it can hold what information? USN as well as semester. So I can mention the data type as student underscore REC. So like this we can able to define our own data type according to the requirement. That is what it is explained here. An object of a record type is an object that can consist of multiple elements of different data types. Here I gave the example of only one data type, that is nothing but bit vector. But here I have taken the example of std underscore logic as well as integer. So like this multiple data type it can hold. And then individual field of the record can be referred by element name. Like how if I want to update only USN, what I will going to do? I'll going to mention a dot USN. So I can access the corresponding field USN and I can able to update the value of USN. Like how we are having USN as well as semester, in the same way we can have one more field like marks and all, or attendance. So like this we can able to consider how many fields we want, we can able to define. Okay, and each variable will be having of those many number of fields. Like this we are going to consider record data type, and this is for user convenience, not for the programming. Only user can able to segregate the corresponding data which is given for the circuit. So that is the purpose we are going to consider record data type, which is convenient for user to handle the data. And next what we are having is data types and subtypes. As I told, a data type means in general it will be having all the set of elements. In that set, if you want to select a part of the set, In that case, we are going to call it as subtype. So here we can able to consider an example. I am defining a subtype by name as byte, and it belongs to the data type bit underscore vector. Okay, and its range is 7 down to 0. So whenever I declare any signal of type byte, means each signal is having is 8 elements, and each element is of type bit, because in bit vector every element is of type bit. So as a result, here also every element is of type bit and its size is fixed, because I have defined it as byte. I need not necessary to mention again and again bit vector 7 down to 0, bit vector 7 down to 0. Simply, if once I define a byte, I can use the data type whenever we want. Okay, this is how we can able to define a subtype. Previously we have taken an example of defining a type, required type, and in that type, if we want subtype, we can able to define like this. Okay, so this is similar to this signal. See, if I do not define a subtype, then for every signal I need to mention this byte 1 byte 2 signals are of type bit vector 7 down to 0. If I do not mention, if I do not want to mention this repeatedly, I can define this as a subtype and I can use the subtype. If I want to change the dimension, what happens? Only in this subtype I will change the dimension. Then the changed value will be reflected in all the signals. Yeah, suppose if I do not define the subtype, in that case, if I want to change the dimension, means in all these statements I have to change. If I miss any one of the statement, then I may get error. So in order to avoid such things, we will going to define subtypes and then we are going to use according to the requirement. And the last part what we are having is attribute. When we are going to consider attribute, this attribute will going to provide information about the entities or architectures or any of the signals like this. So what type of information they are going to give, so that we have to consider. So for example, if I am going to define any particular signal, if I mention signal A of type bit, so in that case, it will going to tell that it can hold the value 0, because the lowest value present in the data type is bit by default. I mean 0 by default. Otherwise, I can able to initialize. Similarly, when I am going to declare an integer signal, in that case, if I do not initialize, its initial value will be equal to 2 raised to minus 2 raised to 31 minus 1. So like this it will going to tell. And value attributes. So one of the scalar attribute what we are having is value attribute. So here we are having tick left, tick right and tick high, low, length, like this. We are going to consider this. And here when we are going to consider tick left, the leftmost value present in the particular element or in the particular data type will be accessed. For example, when we want to consider only rising edge of the clock, okay, if we are having a clock signal like this, in that case I just want to identify the positive edge of the clock as well as negative edges. So in that case what we are going to do is we will going to consider clock tick event. So if I mention the signal as clock, then we will going to consider clock tick event. So what it will going to do, whenever an event occurs, okay, event. So whenever an event occurs on the clock, then it will going to recognize. Event occurring means change in the value we can able to identify. If some event occurs, then only value will change, otherwise value will remain constant. As the value of clock has been changed from 0 to 1 means some event has been occurred, so it will going to identify the occurrence of the event. So the event is an attribute, means when the change in value occurs, that is considered as event. And in order to recognize that, we are going to use the tick attribute, tick event, where tick event represents attribute of a particular signal. And what is that attribute? Change in value is considered as a attribute. So like this we are going to consider attributes. In the same way, we are having tick right, means the rightmost element present in the field data type will be returned. And similarly, tick high means the highest value present in the data type. Tick low, like this we can able to get. If I want to measure length of the given array or the given element, then I can consider tick length. So like this we can able to consider the attributes, means it gives information about the signals or data types or architecture that are already defined. Okay, and some of the predefined attributes are like this. Okay, and here one more thing what we are considering is when we consider vector, so in that case we should know whether we are considering the what is the highest position present in the vector and what is the least position or the highest value or the lowest value and all. So in such case, here we have considered an example that tick high yields the value at the right of the keyword to, or to the left of the keyword down to. For example, let me consider signal A or signal A bit underscore vector. Here I will mention the dimension as 3 down to 0. Okay. So here what happens is, when I mention tick high, A tick high. Okay, if I mention like this, then it has to indicate what is the highest range present in the vector. So when we consider down to, 3 is present on left side of the keyword down to. So there is a spelling mistake, right? So when we consider down to, we are having the the number 3 on left side of the down to. So as a result, between 0 and 3, 3 is the highest value. So it will return 3 as the value. And similarly, instead of this, if I declare any signal B of type bit vector 0 to 5. So if I mention like this, then for an attribute B tick high, it will going to return 5. In this case, it will going to return 3, and in the second example, it will going to return 5, because between 0 and 5, 5 is the highest range position. So it will going to take 5 and this will be considered as 3. So that is why when the keyword 2 is there, in that case right side for the 2 is maximum, and when the keyword down to is there, left side for the keyword is having maximum count. That value it will going to yield, means it will going to give. Similarly, when I mention tick low, it's reverse, means for the left side of the keyword 2 we are having 0, and for right side of the keyword down to we are having 0. That will be returned. So like this we are going to consider. And similarly, to measure the length, we are going to consider tick length. So like this, various attributes which will give the required information of the signal or data type will be considered. And one more example we are having here. I have considered the type count, and this is it can hold integer data in the range 0 to 127. So whenever I am going to declare any signal of type count, it can hold integer value, and that value should be within 0 to 127. So as a result, if I mention count tick left, what it will going to do? Left means here I have taken the leftmost value, so it is 0. So right, if I mention count tick right, then it will going to give 127. And if I mention high, between 0 and 127, highest is 127, so it will give 127. And low, it is 0. And what is the length? 0 to 127 means totally 128 values it can hold. So the total length is 128. Like this, we can able to get the corresponding required data using the attributes. Okay, each attribute is referred with a tick value. And as I told in the previous slide, in order to recognize event occurring on the signal, we are going to consider tick event. In the same way, here also we are going to use tick left, right, high, low, length, all these things for a scalar data type. And here also in a composite data type, where word is a array of 16 bits. So in that case, we can able to consider what is the leftmost bit in this, that is the 15th, and rightmost bit, highest, lowest, length, all these things we can able to measure. And here states, so see, in this case we have considered integer as well as vector, but here this is a user defined state, that is idle, decision, read, write. So in this, the leftmost value is idle and the rightmost value is write, and highest value is write, because as I told, when we define any particular data type, always the first element will be considered as the lowest element present in the array, means the value given for the first element will be less and the value given for the last element will be more. So like this, idle is less than decision, and decision is less than read, and read is less than write. So the highest value in this data type is write. So when I mention state tick idle, sorry, high, it will going to return write. Similarly, I can get the lowest value, that is nothing but idle. And totally how many number of elements are there? 4. So state tick length will going to give the total number of elements. Like this, we can able to get the information. Okay. And yeah, so in the same way, we are going to consider attributes. So like for clock, as I told tick event, here I have taken an example of tick event in order to recognize change in the value of clock signal. And similarly, the last word what we are having is range. In order to identify the range, we are going to use tick range. Okay, highest range, lowest range, all these things we can able to consider.